Right. Today we'll start with circles. Okay. Now circles is a slightly overwhelming topic for a lot of students, and we'll try to overcome this particular difficulty. Let's try to segregate this entire topic into multiple sections, right? So I'll just discuss the overview, how exactly we are going to proceed in today's class, right? Let's see. So the first thing I'm going to take up is the donut concept, right? Donut concept, we know what is a donut, right? This is a circle and inside we have another circle, right? So we can be asked to find the area of the outer part or the inner part or the circumference or the perimeter, whatever it is, correct? We'll take up the donut. Then we will take up equation of a circle, right? Equation of a circle we are going to cover. We have actually touched upon it in the quadratics class, right? Okay. Right. Done?
Good.
Okay. Third concept is the arc concept, arc plus other theorems that may come handy in exam. That's it. These three concepts and you're done with circles topic. Okay. Whatever is required, we are just going to cover that much and nothing more, nothing less. Right? So first, let's take the donut concept. What do you mean by donut? Any idea? We've understood the diagrammatic approach, but any idea what do you mean by donut?
With a circle in a circle.
It's a circle in a circle. And here, see, you are going to be asked majorly upon the area of the shaded region, right? So this is a circle, let's say. Okay. So you can be asked to find the area of the shaded region, isn't it? And you will have to find the bigger circle area minus the inner circle, right? So that is how you're supposed to find the donut questions. Okay. Donut questions, how you're supposed to find? Just subtract the area of the smaller figure from the area of the bigger figure. Okay. Area of the bigger figure minus area of the smaller figure. Okay. You will get your answers. You might also be asked to find the perimeter of the shaded region. So again, perimeter of the bigger circle and subtract it by the perimeter of the smaller figure. Got it? That's it. Subtraction is the key and you're good to go. Let's take up two questions. Okay. Question 10 and question 11, please. Donut questions. Shall we?
Yes, ma'am.
All right. Come on. When we take up 10th question, tell me, what is the answer there? It is 2. Beautiful. Okay. When we talk about the area, this is the most, entry level question, I would say. Okay. So I would just subtract 8 from 10. I would get 2. Okay. Area of the shaded region. Now let's take question 11. Tell me, what is the answer? What is it? Option A. Good. Option A is my answer, right? So let's just quickly discuss, right, this part. How do we solve it? Basically, I have my area of the larger circle, right? And I know the area is pi r square. Okay. Now r is going to be 8. So pi 8 square, that is 64 pi, isn't it? And the radius of the smaller circle is what?
Will be 4 because the diameter of the
half
bigger smaller circle.
the radius of the larger circle. Okay, correct. So over here, the area of the smaller circle becomes 4. Okay, smaller circle is 4. So pi 4 square. Got it? I had 8 for bigger and smaller is going to be 4. So I have 16 pi. Got it? Subtract it, you get 48 pi.
Yes, ma'am.
Yeah, right. Now let's take up equation of a circle. We have already covered it earlier, isn't it? Equation of a circle. So
ma'am.
what is it? Equation of a circle?
Minus x squared plus y minus k squared y squared.
Yeah. Please check your audio connection. It is breaking a lot. Yeah.
Yes, yes,
So
ma'am.
equation of a circle is basically we have already taken up in the quadratics, right? This question is ranked as a medium or even a hard question, right? But if you're aware of the formula, it becomes super easy for you to solve. Okay, what is it? X minus h whole square plus y minus k whole square is equal to r square. Okay, where h and k are nothing but center of a circle. Okay, center of a circle. Please keep in mind that we have put x minus h. So my center is h, right? Over here, it's not minus h. They can confuse you with the plus minus merely, right? And just memorize this formula and you will gain points on your SAT score, guaranteed, right? Okay, all right. Here, let's see. We can take up a couple of questions. Okay, so basically what we are going to do is we are going to solve question 12 to 18. Okay, question 12 to question 18. Come on. Question 12 to question 18. Let's try 7 questions right now. Okay. And let's allocate till 4:53 p.m. Right? Let's see. So 12, what is the answer?
C.
C, absolutely correct. Very straightforward elementary question. Correct? You have 4 and 2, and you have radius as 5. Do not mark, 5. This is a common error, right? Where they end up marking 5. It's square always. Okay, next. 13.
13.
13 is what? 13 is A? Yeah, correct. This question basically describes a circle, right? 8 inches from a given point in the plane. So 8 inches from a given point, correct? Everywhere it is 8 inches. So this becomes a radius. Okay, remember that radius is the distance from a center to the circle, and the diameter is twice that distance. So it is twice the radius. Okay, 16 has to be the diameter. Got it?
Yes, ma'am.
14.
C.
14 is C, absolutely correct. Yes. So over here, what is the center of a circle? I will have to be very careful of the negative positive part. Okay. So it is C, 8, -2, right? Okay, 15.
D.
D is correct. Very nice. Okay. So I have 5 and y plus 3. Okay. And radius is square of it. Very good. You're doing amazing. Okay, 16. Tell me.
15. I wasn't able to get that.
Okay, now see, when we are taking question 16, right? So when a picture is described and it's not really shown, okay, just try to draw it once. What it is said that it has a center of 1,4, right? So this is 1,4, isn't it? And tangent to the y-axis. So this is my y-axis. It's tangent to the y-axis. Got it? So our sketch shows that it has a radius of what? Radius of 1, right?
Yes, ma'am.
Correct? This is the x-axis. This is 1. Okay, so radius is going to be 1.
D.
Exactly. Now h is what? H is going to be 1 and k is going to be 4. With these 3 information, it's enough to answer, right? D is absolutely correct, okay? Easy stuff. Yeah, slightly twisted question, I would say, like around 660 level. 17, tell me. What is it? D? Correct. Absolutely correct. Right? Tangent to x-axis and tangent to y-axis at 3 each. Again, you can draw it and you can see that it is, my radius is going to be 3. Okay, so option D works. Absolutely correct. Now please watch out for option D, all right, which looks okay but has a minus sign instead of a plus sign between the parentheses. Got it? Yeah, this part is incorrect, or else B would be correct. Yeah, of course, 2 correct option I don't have. Okay, come on, last question. 18. Here, what is the answer? 25. No. So basically, we have to complete the square, what we've learned in the quadratics class, right? So what do we get after completing the square? It is x plus 3, right? Whole square plus y minus 2 whole square is equal to 25. Now my radius is r square, isn't it? My equation says this is r square, so r has to be 5. Got it? Yes? In one of the options, they will put 25. Had it been an MCQ question. It's 5, my answer. Clear? Yeah? So what all we have covered so far? The donut part we have covered, right? Done. Equation of a circle, done. Okay? Now we are left with little bit of theory. Okay? Theory and arc. It actually comes under theory only. But I'm stating it separately because this is really an important type of question that will be tested. They love our questions. Okay? So I have put the theorem over here itself for your reference. You don't have to write anything down. Point to note. First is central angle is AOB. Remember, this is my central angle. Okay? This is my central angle. And this is more than 180. Okay? Acute, obtuse. Inscribed angle is ACB, right? This is my inscribed angle. Within the figure, plane figure, 2D, 3D, we have inscribed angle. Okay? Now I want you to learn these 2 languages, major arc, minor arc, right? So major arc is basically ACB. Okay? This entire. Like suppose I'm breaking down a circle. This is a circle and this is suppose like a pizza slice. I take out one pizza slice. Okay. So whatever is the remaining portion now, that is major arc. Okay. And this part is called the minor arc. Got it? This is my major arc. I hope this is clear. This entire part is my major arc and this part is my minor arc. Okay. See, minor arc is AB. This much only. Clear? This is very, very important. Going to be asked later. Central angle, you can know this, they might or they may or may not ask questions from here, but still, like I've actually jotted it down, right? You should know this. Central angle is 2x of inscribed angle. So suppose I have this as x, right? This becomes 2x, central angle. Got it? Inscribed angle, 2x. Yes, sir. Clear? Now, next is, if you have a circle, right? And if you have a triangle, that basically one of the sides of the triangle cuts the circle into 2 equal parts. That is a semicircle. Okay. It's basically the diameter. Okay. If one of the sides is a diameter, right? That it cuts from the center. That means my triangle becomes a right angle triangle. When I'm going to take a triangle topic, I will discuss a couple of rules of right angle. You will have 2 special rules. These are called special triangles, right? So these special triangles, no, we are going to consider. Okay. Simple stuff, no? What all we covered? Central angle, inscribed angle. What is the relationship between central and inscribed? Inscribed is x, so central is double of that. Remember. Yes, Okay, my major arc, minor arc, pizza slice, right? The major portion is a major arc, minor is a smaller portion, right? And this diameter, if one side is a diameter, then the triangle becomes right angle triangle.
Okay.
Okay. Now, what is this? What is this? What is this? APA is equal to BP. Okay. Suppose this is equal. All right. An angle AOB plus angle APB. Okay. This plus this angle is 180. Okay. Opposite angles are 180 degrees. Addition of it. Correct. So what can I say? That this is your perpendicular and this is your perpendicular. Got it? Understood the rule, na? Right? If these two lines are equal, see again, this is not very much tested in your exam. Still, you should know, worst case scenario. And the opposite angles are going to add up to 180. So my angle is 90 degrees. Okay. This becomes 90 degrees. Okay. Now this you should know in your school also, you must have covered opposite angles add up to 180, right? Opposite angles, that's what A and C add up to 180. Same for B and D, right? Within a circle, if all the sides, they touch the circumference. Here, this is also not much tested. Ninth, that A times B. Please remember this. If let's say in a circle, you have like two lines, right? That intersect. Please remember that A times B, you multiply this section, okay? First and second section, and you equate it with the second line division, okay? C times D. Got it? Right? We're going to revise everything. For 10, 10 is important. It's heavily tested, okay? 10 is very, very important. Arc, right? So suppose I am taking, be very, very attentive over here. You will get amazing questions. Suppose this is a circle, okay? And I have, tell me any angle, any number.
90.
70? Okay. Let's take 70 degrees, okay? And let's say this is what, my minor arc, no? This is my minor arc. Huh? Give me any number from 1 to 10.
10.
Okay. 10. Okay. All right. Okay. So consider this particular circle. My radius is R. All right. And my circumference is what? What is the formula of circumference again? 2 pi R, no? And let's say I'm just marking it C for now. Got it? Now, we are going to cover this extensively in ratios chapter, where we are taking part by whole. I'm sure that this is not new to you. You must have covered it in your school extensively, right? Part by whole, right? Just remember that when we want to find the length, let's say instead of 10, I write S, okay? If you want to find the length of S, right? Length of S, that is length of the minor arc. We have to find, okay? So what is given? This is a circle. This is central angle is 70 degrees. I am just keeping for now the length as S, okay? And my radius is given, okay? Let's say radius I'll take as 10, what you have mentioned instead. So how do I find the length of S? Part by whole, okay? So first I will take part. This is a circumference, no? Entire part, right?
Yes.
Be very careful, okay, here. This is a circumference. So my part is this. This is a chunk out of the circumference, correct? This S is a chunk out of the circumference. From the entire pizza, you take out one slice. So that is a chunk out of the entire circumference, right? Okay. So can I write part by whole? Part by whole as S over whole is what? This entire whole is what? Circumference? Correct? Can I write circumference? Part by whole? Think about it.
Yes, sir.
Yes. Okay. Right. So my part by whole concept, extremely important. Okay. So part of the circle, it's S, right? Taken out a part. And the whole is circumference. And I want to find the length of S, right? I will equate it. I'll set up a proportion. I will equate it with degrees. What is a part degree? Part degree of this particular pizza slice? What is it? 70, no? Correct? 70 degrees is the part. Whole, what is the total degree?
290.
No, total degree, not the leftover degree. What is this? 360, no?
Yes.
Correct. So this is 360 degree. Clear?
Yes,
Yeah.
ma'am.
This is in degrees. Okay. This is in degrees. Now I'm going to write in radians. Right? Radians is where pi is involved, right? So S divided by circumference is what? 2 pi r, right? Is equal to 70 degree divided by 2 pi. Can I write? Think about it. This is what? 2 pi, no? Right? This is 2 pi. Is it clear? Yeah?
Yes, ma'am.
Yes. R I can now solve. Let's solve it, guys. This one. R. So I have what? S. I'll write it here. S 2 pi r. And I have 70 divided by 2 pi. Correct? So R I can get from here itself. Right? S divided by 2 times 10 pi. Right? 70 by 2 pi. Right? Can I cancel pi and pi? Pi
Yeah.
will get cancelled, no? So S is what? 70
Madam.
times 2 times 10 divided by 2. Is it clear?
Yes, ma'am.
Yes. So that is my answer, whatever it is, 700. Any doubt?
No, ma'am.
Correct? Arc is nothing but part over whole concept, okay? Please remember, part over whole, right? So what did we do? Again, let's draw it. Circle, arc, right? This is my central angle, 70 degrees. Or let's say the central angle, I'm generalizing it now. Central angle is theta, okay? And I'm taking my length of this particular minor arc as S. Yeah? Come on. Yeah?
Yes.
S. I have this as R. Generalizing it. What do I write? S over circumference, no?
Yes, ma'am.
Pi R is equal to what? Degrees. Okay?
Yes, ma'am.
Length. First take the length divided by the whole length is equal to degrees. Part degree by whole degree. Okay? So
Yes, ma'am.
theta by 2 pi.
2 pi.
Yeah. So what do you have? Can I cancel 2 pi, 2 pi?
Yes, ma'am.
What do I have? Theta r. Got it?
Yes, ma'am.
Your formula becomes theta r for length of the arc. You can remember the formula also. Okay?
Yes, ma'am.
Your derivation, I personally feel that the more formulas you learn, especially in geometry, the confusing it gets, right? So because anyway, you will have a lot of formula later also, right? 2D, 3D, other figures, coordinate geometry and everything. So let's try to cut down on the formulas. Our questions, try to use part over whole. I personally like part over whole better as compared to this formula, right? But if you're aware of this formula, sometimes in the exam, no, you can immediately answer, right? You have, let's say 70 and you have 10, right? You can immediately answer to 700 without even solving. Got it?
No.
They asked length. What is it? 10 times 70. Done. Move on to the next question. 5 seconds work. Got it? Is it clear? Did you
Well,
write it down? Yes. Ask any doubt.
No, ma'am.
Easy topic. Easy topic. And actually, this part, the next theory, what I'm going to take up, based on arc only, that's the last theory for the class. And we are done. Theory-wise, we are done. Then we can just target to solve as many questions as possible. Right? Up until 790 questions I'm going to take today. Clear?
Yes, ma'am.
Yeah. Now we will work upon area. So if we see R questions, now only two types of R questions you can get. One is what is the length of it, right? So suppose this is a minor arc, they will ask what is the length? S. Okay, they will ask what is the length. Got it? Second type of question what you can get is this area. Okay, area question you can get. Let me just write it a little bit below. So length and area. Okay, so length is basically S. And what is area? Area is area of the sector. This particular part is called the sector. Length of arc and area. This is my sector. Okay. One question I can get is length. What do I know? Length is calculated as theta r. Okay. This is theta and this is r, right? Just multiply it, you get the length. Alternatively, you can use part over whole concept. Understood? Part over whole. Clear?
Yes, ma'am.
Now, part over whole, now you can use here also, area. Right? How can I use part over whole? So suppose, I have this question where I am being given the area to find, right? Let's say this is A, right? Part over whole, let's try to put in part over whole. So what is the area of the sector? A, part is A, right? Whole area is what? Whole area? Pi r square, whole area, whole circle area is pi r square, is equal to degree. Same, I'll put 70 degrees, okay? Okay, 70 degrees divided by whole area is what? 360 degrees. Right hand side is the same. Right hand side is the same. Even for length, what did I do? S divided by 2 pi r, no? For length. The right hand side was the same, 360 degrees, 70 by 360 degrees. Did you understand? Yeah. So A over pi r square, I can just plug in pi r square. Let's put everything in radians here. So I have 2 pi. Okay. I have over here 2 pi and 360, I'll put it as 2 pi. Okay. That's it. This is my shortcut. Okay. This is how I'll solve the questions. A over pi r square is equal to 70 over 2 pi. So I'll just, I can solve for this. I have my radius as what? 10. Correct? Radius is 10 and theta is what? 70 degrees? Okay, so let's just do one thing. Let's just plug it in over here. We can put it as 360 for this one. And r square is 10 square. Right? We can solve for this. Alternatively, if I'm going to just show you a formula, there's an easier way. If you're aware of the formula, it becomes easier to solve. Okay.
Isn't it like theta by 360 into pi r square?
Yeah, we'll be seeing that. A over pi r square is equal to, I have 70. 70 is, I'll just keep it as theta for now, divided by whole is 2 pi. Okay. So I will just cross multiply. A is equal to pi r square times theta over 2 pi, right? And this becomes what? Pi cancels out and it's going to be half theta r square. Okay. This is my formula for area of a sector. Okay. Area of a sector formula is half theta r square. Length of a particular arc, minor arc, is theta r. Clear? Yes?
Yes, ma'am.
It's an amazing set of questions. You will get amazing questions from here, right? This is by far one of the most important chunks of entire circle concept, apart from equation of a circle, right? We've taken a couple of good equation of a circle questions.
This works.
Sorry?
These shortcut formulas work. Like,
that's why we are taking up.
okay, can you give some examples on these formulas?
Yeah, we're going to take questions.
Okay, ma'am.
Write it down first. Understand the concept really, really well. Okay. I personally feel that part over whole concept is really, really easy, right? But if you're keen in learning the formulae, you can go ahead and learn. Length is theta r and area is half theta r square. Okay. But I still will encourage you to use part over whole concept. Okay. I'm going to give you 30 seconds to please go through the formula. We are done. The handout theory is done. Everything is completed. Now we'll just solve as many questions as possible, whatever leftover questions we have. Write this down really well. Most of the questions will be based upon arcs, right? This should go in your formula book, okay? If I just scroll up. Yeah, see, I've actually put it over here also. The length of the minor arc is r theta and area is half r square theta. This we have already found, right? And the shortcut formula is part over whole concept. Okay. And pi is nothing but 180 degrees. You must know this. Okay. Radian measure, sometimes you may be asked to convert from degree to radians to degrees. Okay, there is one very, very easy method. What I personally follow, if I have, let's say in radians, right? I need my answer in pi. So I need pi in the numerator. Okay, I need pi in the numerator. So I will be taking pi over 180. Okay, whereas if I want to get radians to degrees, I need to get rid of pi. Okay, get rid of pi because I need in degrees now. So I will divide by pi. This is one method that I personally follow because sometimes what I have seen is students get confused that when it is pi by 180 and when it is 180 by pi. They know that it is something related to 180 and pi, but they don't know that when it is going to be in the numerator and when pi goes to the denominator. So this is one very nice way to learn shortcut. Okay. That's it, guys. Theory is done for the day. Let's practice as many questions as possible. Okay, couple of must-do questions I have listed down. And the other set of questions, if we have time, we'll cover it. Okay. Let's first take questions 5 through 8. Question 5 through 8, based on whatever theory we have learned today, please focus upon these questions. Question 5 through question 8. So I'm going to give you for these 4 questions 7 minutes. I think that's pretty decent. Good questions, all these questions are. 7 minutes, that is 24. Right? Take till 5:25, that's all right.
Mom, which handout is this? Which
9.
handout is this?
9. Right. Let's see question 5 first. Yeah, this question. Let's go. What is the answer? A, 4 pi? Okay.
I got, hold on. I also got 4 pi.
4 pi is wrong. Let's see. Remember that particular theorem? that, we are actually connecting radius? Yes.
Mom, when you use theta by 360 into 2 pi, you get 4 pi.
Let's see. We're going to solve this question. So remember that, these two particular angles will add up to 180, right? We've covered this theory. So this is 120 degrees, no? Right? This is 120 degrees, clear? And my radius is 12. Okay? So what is the length of the minor arc PR? So this PR becomes what? Over here, PR is going to be, tell me. I need to convert this degree into radians. 120 is what? 24 pi? Think about it, guys. 120, let's do it together. I need to get the pi, right? So pi over 180. Right? Yes? Are you with me?
Yeah.
Yeah? So what do I have? 6 3s are 6 2s are 2 pi by 3. Okay? My central angle is 2 pi by 3. So theta is 2 pi over 3. And my radius is 12. What is the arc? It's you just multiply it, right? Theta r. So you get by 3 times 12. So you take 4, 8 pi. Done.
Ma'am, could you please try using theta by 360 once? Because I feel like...
Yes, theta by 360 also we can do. But this is clear, right? With the formula, how do I get my answer? 8 pi.
Ma'am, could you just try theta by 360 once?
Yes, Risha. I'm going to take it now. This is clear? The formula base is clear, right?
Yeah.
So this is 2 pi by 3 and 12, right? This is what we deduced. All right. Now, if I take, let's say, part over whole concept, that way also we'll get an answer.
Okay, wait. So we have to take the angle is 2 pi by 3.
Sorry?
We take the angle is 2 pi by 3.
Yeah.
Okay, I got it.
So,
yeah.
Let's see. Part over whole, what do I get? My part is going to be PR, right? So let's name this part as S. Okay. Divided by whole, that is 2 pi r, correct? Is equal to, my angle side is going to be 2 pi by 3 divided by 2 pi. Okay. That's your 360 degrees. Okay. 360 is 2 pi angle wise. So here actually 2 pi gets cancelled. So I have S, I'll plug in R. I'll have 24 pi is equal to, what do I have? 1 over 3, right? So if you take S, that's going to be 24 pi by 3. I'll still get 8 pi, okay? Both ways you get the right answer. 8 pi. Understood?
I said only.
Huh?
You said 8 pi only.
Yes, 8 pi. Good. Right? Both ways we get our answer. It's a decent question. Actually, we have to take up the previous theorems, right? We have 3 concepts merged into one question. So we have that, opposite angles 181, right? That tangent theorem, what we have covered, 1. Second is the radians to degrees or degrees to radians, that theory. Third is your arc, right? Sixth, let's see, what is the answer?
75.
75 is absolutely correct. Okay. You just have to take 180 minus 105. You get 75, right? We've taken the theory also. Very nice. Let's see. Question 7. 7 and 8 we'll do together. Okay. Come on. Question 7. Decent question it is. What do I get?
7th one, I got 15 pi.
15 pi is absolutely right. Okay. Minor arc is nothing but r theta. Okay. You can use part over whole also. Nothing is wrong. So you just have to multiply 36 times 5 pi by 12. Okay. You get 15 pi. Right? 8. What is the answer? Let's go. C. Right. I'll again use my formula half r square theta. You can use part over whole. You'll get the same answer. Okay, you will get 270 pi. Okay, 270 pi. These questions, right? These two questions, 7 and 8, are direct questions. You shouldn't get these two questions wrong. If you get it wrong, that means your base is not strong, right? Something is wrong with your foundation. You have to go back and revise the theory. Okay, these are the easiest lot. Okay, so actually, we are done with the questions. We still have half an hour. So I want to, practice couple of questions. I'll do something. We will take equation of a circle. I want to take like approximately 3 questions. Okay, and based on this particular arc and all the theorems, we have, I'll just show you what are the questions for equation of a circle. We have from question 1 to 4 and question 9 based on equation of a circle. You can note it down. And on the theorems, all the different like 10, 11 theorems what we have covered, we have from question 19 till 30. Okay, question 19 till 30 we have, guys. So approximately like 12 questions, right? So these many questions are left. Let's see if we can, cover the entire chunk. I don't think we'll be able to cover the entire chunk, but let's try to cover as much as possible. First, let's take the equation of a circle, slightly advanced questions. So let's take up from 1 to 4. Okay, let's try from 1 to 4, guys. Quadratics also, it's carried forward in this handout. Questions 1 to 4, guys. Equations of a circle, right? The faster you solve the questions, the more questions we can cover, right? Just let me know when you're done. We'll go to the next set. I'll discuss and then go to the next set. Come on, let's go. Right, let's see. Come on, question 1. What is it? What is question 1 answer? Come on, come on, come on.
C.
C, right?
Let's see.
C, right? Okay. Completing the square, what we've learned in quadratics, just use the same formula. Okay. Question 2.
A.
Question 2 is A, right? Circumference is 2 pi r, 10 pi you'll get. Perfect. 3. What is it? Interesting question this is. Come on, you can do it. Yeah?
Mom, is it 7?
No, it's 9.
Alright. I think I did made a mistake.
Yeah? See, can I say this, this is particular y, right? Over here, this is y. 15 is x and 6 is y. That means this is what? 6, correct? Yes, guys. It's a very simple question, actually. Super simple question. This is 6. This is my radius. Because from a point to the circle, it is going to be constant, right? Radius becomes constant. So this is also 6, right? Understood? This is 15. So this k becomes what? 9. 15 minus 6. How's it? Observe, guys.
Yeah, I got it.
It's a very interesting question.
Yeah.
Very interesting. Okay, Siddham, tell me. Yeah? How was it? Easy stuff, okay? Let's go. Question 4. Last question. What is it? Yeah. It's a parabola. Can you say that? Quadratics. Yeah. How I'll solve this? I'll use axis of symmetry, guys. Okay. Remember axisymmetry, quadratics. Never forget it. How do I find it? I have roots, right? So I'll just take the midpoint of it. Okay. -2 plus 8 by 2. Do you agree with me? I'll take the midpoint and I'll get my axis of symmetry. 6 by 2 is 3. Okay. Axis symmetry is 3. This is 3, 0. Can I say that? Yeah. Now, basically, they are asking that, which one is equal to 3. Suppose I take 0, 7. So 0 plus 7 by 2, right? 3.5 I'm getting. Like that, 1 plus 6, option B, 1 plus 6 by 2, 7 by 2. Again, I'll be getting 3.5, right? Option C is what? 1 plus 5 by 2, 6 by 2, 3 I'm getting. Okay. So yeah, this is my answer. I'll just check for D also. 2 plus 3 by 2. 5 by 2 is 2.5 I'm getting. Clear? Guys, twisted question this was. Right? If you don't understand the language of the question, you will really get confused. Any doubt? Please ask. No? Good question. Very good question this was. So it's like a mix of, in a way, it is quadratic question, right? In the form of a semicircle. So you are understanding, right? Semicircle and quadratics, how much overlap it has, right? Semicircle, you can view it as a quadratic. And you can use all the quadratic theory that you've covered earlier. Okay? All right. This we have covered already. Let's see. We still have time. Let's take up more questions. I don't want to waste even a single minute. Okay, let's take from the bottom up, right? 30, 29. Okay, let's do one thing. We can take up from 27 till 30. Okay, 27 till 30. '27 till 30. Yep. 27. Let's go for 27th question first. Yeah. Come on. What is the answer, guys?
4.
4. Okay. Rishi,
Yeah,
what?
4 too.
Yeah. 4 as well. Okay. All right. Let's see. How will you solve this question?
Yes, ma'am.
Yeah.
And so the area will be pi into d by 2 whole square. So that will be pi into d square by 4. Now we will double the diameter. So the new area will be 4 pi d square by 4 is equal to pi d square. So it will be 4 times the first area the actual area.
You guys made a calculation error. The question is what percent it is increased, right? What percent has it increased? The change in the percentage, right? So I'll show you two ways to solve it. One using a pan strategy and one how you have actually discussed Siddham. Okay. First, I'll take Siddham's approach and I'll tell you that where exactly you made a mistake. So first, what you said that area is what? Pi r square, right? So my new circle is what? Diameter is doubled. Diameter is doubled, right? So what do I have? Area of a new circle is pi. This is old, okay? New is what? Pi 2r square, right?
Yes, ma'am.
2r whole square. Do you agree with me?
Yes, ma'am.
Yeah. Okay. All right. So what is the change? Let me just simplify this. This is what? 4 pi r square, no? Correct? 4 pi r square, all right? Now I have to find the change, increased. So I need to find the change. Change is what? 4 pi r square minus pi r square. New minus old. What do I get? 3 pi r square. Everyone agrees? Yes? 3 pi r square, no? Clear so far? Yeah? Yes?
Yeah,
I
ma'am.
r 2r and I'll be getting 3 pi r square. Okay, so my area has increased by what? Increase, what do I calculate? Change by initial, right?
Yes, ma'am.
Times 100, percentage. So change is what? 3 pi r square. Initial is what? Pi r square, no? Original? Old. Initial is this pi r square, correct? Times 100. This entire bit gets cancelled. Pi r square, pi r square. What is my answer? 300%. Yeah? Clear?
Yeah, got it.
100%.
Okay, got it. Yeah.
Yes. These are good questions. All the questions what we are taking up right now. You know, you guys can practice from 19 till 26. 19 and 26 is also like really nice. 750 plus questions. All the questions. Okay, so 300%. Alternate, I'll just show you one more method using pan strategy, what we discussed in the first class. You can actually pick the diameter. Let's say I'm picking the diameter as 2. So my radius is what? 1, correct? Half is my radius. Clear, right? 2 by 2 is 1. Now, it has doubled. So my new diameter is 4, correct? Radius is what? 2. Everyone agrees, right? Radius is 2. I'm picking a number. Now, what is the formula? What is the area? Area is what? Anyone? 4 pi, correct? Pi r square 4 pi. And for the previous one, area is what? Just pi, no? Correct? Pi r square. So r is 1. Everyone? Siddham, do you agree?
Yes, ma'am.
Old area is 4 pi. Now I'll just subtract it. 3 pi divided by pi times 100. I will still get 300. Okay? Understood this question? Good question. Right? 28. Please tell me. 28. Yeah. Good one. Tell me. Yeah. Rishi, what did you get? 28.
Mom, 28, I had a doubt in it. I didn't like, in the middle, I feel like I made a mistakes and I didn't know what to do in the middle of it. So I needed help with this question.
Okay. Any starter, like any point where we can start off?
The triangles are right angle triangle.
Correct. Very good, Siddham. Right angle triangle. So it is a Pythagoras theorem. Okay, we can apply here. Right? See, the hypotenuse of each triangle is radius, no?
Yes, ma'am.
You see that? This is my radius. This is my radius. So this is nothing but hypotenuse. Clear? Yeah? By Pythagoras theorem, what do I get? Let's say if I take it first and second. Okay? So for the first one, Pythagoras theorem says what? Who can tell me? Quick. Pythagoras theorem. Yes.
So that specific line will be
Triangle. Not
yeah,
line.
sorry. You know, that specific radius part will be basically, since it's a square plus b square is equal to r square,
Correct. Very good.
and
Second
then c square plus d square is equal to r square. So a square plus b square is equal to c square plus d square.
I can like now solve it, no?
Yeah.
Right?
So you get 2a square plus 2b square is equal to 15.
So you add everything. This one it was a square plus b square plus c square plus d square is equal to 2r square, right? But I have it as 15. So can I equate it?
Yeah.
15 is equal to 2r square, guys. Easy. Yeah.
Hmm.
Super simple question. Why it is difficult? Because it looks tricky at first, but just be calm. All right, you got it. Right?
But ma'am, why can't you take c square plus d square is a square plus b square?
Yeah, you can do that also. Why I'm doing it? Because why I'm taking this approach? Because my first question is a square plus b square plus c square plus d square, right? Okay. So the first thing is that we can actually add everything. So at least we can get some part of the question, right? So we can solve it in any way possible. Just remember one thing, that don't confuse yourself in between,
Right.
right? And don't complicate the question. Always keep an eye on the end point, like what exactly is required, because one question can go in multiple directions. We can use our knowledge, that's separate, but go as per the question. That is more important on the SAT. Okay, so I would always recommend that when you write whatever, like, you just get the starting point. What actually Siddham said very, very well, that right angle. Okay, so with that, I can like think, okay, how can I connect the dots? Pythagoras theorem. Okay, I'll see, can I make a Pythagoras theorem out of it, right? An equation. This is R, same, right? This part is going to be the same. So I can get to equation, right? Pythagoras theorem. And once I put it like right on top of each other, I can see that, hey, okay, if I add it, I can get it in this left-hand side format, right? So just let the question take you. Once you start, right, the question will automatically hold your hand, right? And it is going to be with you in every step, right? Don't try to be in a haste to just keep applying your knowledge, right? That is going to be the difference between like a 12, 1300 and a 1500 plus. Focus and believe in yourself and just trust the process, okay? Go step by step, look at the end point, keep an eye on the end point. That's very, very important. Observe. So I can get the value of this thing, right? R. I want to keep it in R square because see, my observation says that area I have to find, right? Area is in R square, correct? Pi R square. So I would want to keep it in terms of R square, right? So 15/2, don't change it into decimal. One thing, you should write it maybe in the formula book. Remember it, never change it into the decimal unless it's asking you to. Keep it in the fraction as much as possible, because decimal will get you confused. Okay, so I can like put it now. This is equal to k pi, no, guys?
Yes.
So pi gets cancelled. My answer is what? 15/2. Done.
Yeah.
Not 7.5.
7.5. Now you can change it into the decimal. Last step you can, but don't do any conversion in the middle, please. Okay, that's my sincere request. 15/2 or 7.5, both are right. Clear? Yeah. Rishi, I hope I've answered your question, right? That why we are not going to add it.
Yeah, got it.
Okay. All right. Very good question. It's okay, guys. We are taking like 5-10 minutes extra. I don't mind, but these questions you should know how to solve. Okay. 29. Just trust the process. Go slow.
C.
What is it?
C.
C or D? I'm not understanding.
C.
C? Very
Yeah.
nice. C is correct. Okay. Rishi, can you explain the process once?
Mom, basically they gave the radius of the large circles is 4, so the diameter between the two, basically the side of the square would be 8, and the diameter between the two circles would be 8 as well. So then what would you would have to find the area of the square, the area of the circles, and then you would have to subtract them, all 4 of them, to get
Yes.
the area of the circle, small circle.
Beautiful. My answer is C. Okay. Actually, you know what? In the triangles chapter, I will take it up. I'll take up a special triangle concept. Okay. This becomes an isosceles triangle. So I can use a 45, 45, 90, you know. This also becomes very easy to solve. I'll discuss it in the triangles class. Very, 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 very important topic. 45, 45, 90 and 30, 60, 90. Special triangle concept is super important. Okay. All right. Beautiful. You guys are smashing it. Last question is really simple.
14.4.
Huh? 14? Sorry, I didn't get you. Could you repeat that, Siddham? Rishi, what did you get?
They gave the length of the arc. So
Yeah.
what you do is you do theta by 360 into 2 pi r is equal to 4 pi.
Correct.
And then you simplify that. You'll find the radius, right?
Yeah.
And then you substitute the radius in theta by 360 into pi r square.
Theta by 360 to pi r square. Correct. What did you get?
Mom, I didn't finish it completely.
Okay.
5184.
Okay, let's solve it together. What's
Yeah.
it, right? So circumference, I can like get the length of the arc that part by whole, okay? I
Yeah.
can get my answer. So what is it? It is, I can take 50 degrees I have, right? 50
50
degrees by 360 part by whole, right? Is
into,
equal to, I have 4 pi, correct?
yeah.
And my entire bit is 2 pi r,
Mm-hmm.
right? So I can get my answer, like what is 2 pi r? I can actually get r.
You need R only.
Yeah.
So you
I'll
can
get
cut 4 pi and 2 pi, you'll get 2 on the top, and then you can take 360 into 2 is equal to 50 R, 360 into 2 by 50.
correct. Simplify it. What did you get?
One second.
Yeah. We're getting 72 by 5.
Yeah, 72 by 5.
Correct? 72 by 5, we just cross multiply and simplify it, okay?
Yeah,
Now, the area of the circle is what? Pi r square?
yeah. So part by whole into pi r square.
Correct. Pi r square, okay?
Yeah.
Yeah, okay. So, I will be taking it as what? I'll find the area of the sector.
Mm-hmm.
No. So, I'll just, actually, I'll take this process once again, correct? So, this is 50 by 360 is equal to my area, what I require. That is what they want us to find. Let's say this is x divided by pi r square. Okay. So r square is 72 by 5 whole square.
Yeah.
Okay. Yes. So you will get your answer.
So you'll get 720 pi by 360.
720 pi. I have not, calculated it, so I'm going to rely upon you. Over
So
here,
720 pi by 360.
720 pi by 360. We can actually
Yes.
simplify it.
Yeah, so it'll be 2 pi.
Fine.
Yeah.
Are you sure? Check your steps once. 72 whole square is what? Let's take it 20. I don't think that's right. What you've calculated, Rishi. 72 whole square. Come on.
Oh, I didn't square it. My bad. Yeah, I didn't square it.
What is the area is 5184?
5184 pi, right? Correct.
Yeah, 5184 pi.
5184 pi divided by 25. Okay.
Yeah.
So
Then it'll be 5184 into 2. 5184 pi into 2 by 360.
The value x is 5184 according to me.
5184, correct. Divided by 25. So I just cross multiply. Simple. 50
Yeah.
times 360 multiplied by
5184 by 25. So
5184 only because it's in the denominator fraction, right?
oh, okay, yeah.
5184 divided by 25 pi. Okay.
Yeah.
Now you will calculate it. What are you going to get? $50, 10. Calculate, guys. You should be getting like 10,368 pi.
1 second.
Yeah. So pi you can actually change 3.14.
Ma'am, 28.8 pi.
Times 3.14.
Okay.
Pi, no? Multiply by pi.
90.4.
Correct.
Can't write 360 as 2 pi, then we just cut the pi.
Yeah. Correct. Yes, we simplified.
Yeah.
90.4. Actually, what is the 100th place? 10th, 100th place?
90.43.
43.
Yes.
Okay. So nearest 10th is 90.4. Okay, that's it. Good question. It's like calculation heavy question. This
Yeah.
one. But make sure that you're not making any mistake. The squaring part, right, or the part over whole. What is going to go in the denominator, numerator, everything. Just make sure that that is being taken care of. That's SAT, guys, for you. Okay. It's not going to be easy to get 1500 plus, but with good observation and regular practice. Okay. That is why in the homework I've included a lot of amazing questions. So please complete that, and the revision handouts also, go for it. Okay. We are done with this Maths 9.